Now for the hex switch. It's always good to have a little dab of solder already on here. I do, but I think I need a little more. Zero, years and years ago, I did not use solder flux. Of course, I wasn't working with surface mount components, but solder flux works really good whether it's surface mount or not. It just really helps spread it. Zoom out so you can get a better picture. So we're almost done. Okay, now for the LEDs. My phone had an issue, so we got the right angle LED here. Got it's a clear lens, but it's red. Light spot goes toward the back of the card. I usually bend the pins out a little bit for that, just to hold it in place, as you can see. I will do the same thing with the capacitor. Now this one definitely has polarity. So always remember positive to the right. And it's labeled on the card. You got negative, positive. Not to mention the diagram or the outline of the actual part. Shows you the lip and everything. Whatever the technical term would be for that. Move those out as well. We have, besides my hairy arm under there, our switches. These select TI, this one selects TI or Geneve mode. And this one you can turn the card off and then TI or Geneve mode. This one, it doesn't matter how you put it in. This one, it only goes in one way. You will see. Flip the card over. And I lost my right angle LED. I'll put that back in. I'll do the switch in a minute. This switch will typically stay in by itself for you to be able to solder. Go ahead and do this LED. lot of times when I clip like LEDs and stuff, I'll go back and reheat each pin just to, I guess I just do it just because I'm anal about it. We'll put the right angle LED in that fell out on me. We will put the other switch in. Well, I'm really having issues. So I usually don't have to work with this little bitty box in my way. Use the two pins that anchor. They're not actually connected to anything besides nothing really. A little bit more solder on this one. We're almost ready to run a test on this card. That's what it is. I'm pushing this thing back too far when I go to solder, so y'all can see. Right here, that's better. Okay, so we're almost done. So the only things we have left to do is we need to install the actual IDE 40-pin connector. We need to install the clock chip and the heatsink. So we're going to go ahead and do the IDE connector. So what you need to see about this is typically most of them will come with all 40 pins. Okay, this one did. But a lot of the new cables you go out and buy, if you're buying your own IDE cable, they're going to have a block in the cable. And let me grab one. A lot of the newer cables come with a block. So, see, there's no pin in pin number 20. So if you buy that, and if you've installed one that has all 40 pins, you're going to have a problem. It won't fit. So the best thing to do is to take pin 20 out. And it's real simple to do. You just move this to the side a little bit. It'll bend a little bit. And then you can just easily push this out with a, with a round bit, something like that. I mean, I used a hex key to push it out with. Real simple to go in. So, yeah, we'll solder all these together. I typically do this on the right side. It's much more easier. almost done. Now, one thing to note about this IDE card, Theory did a real good design on it. Fred has really ramped up on the DSR for this, and I'm very impressed with his DSR on how it works. Even the diagnostics, if something's wrong with the car, with his IDE test program, not the DSR itself, it actually will give you areas to check as far as the ICs and things, which is very nice. So the switches are in. Writes Geneve. Remember Geneve, if you're using this on a Geneve, it will only work currently. It will not work in the MDOS native mode. It will work in the ROM page mode only. Hopefully that will change at some point, but it does work on the Geneve that way. This is off. Middle is Geneve. All the way to the right is TI. So let's grab our clock chip. So I'm not sure whose card this is going to be, but since I'm filling orders, it's going to be someone's. So now we solder the clock chips. And of course you only solder the pins that are actually being connected. The ones that don't come through, you don't have to worry about. Clean my bit off a little bit. Now I've got my test TI set up. It's not the one I use typically all the time, but it's so. Zoom out a little bit for you, just like so. Now we install the heatsink. Well, actually, before we install the heatsink, then you install the voltage regulator. This is a 7805, but of course it's surface mount. I think it's the 263 package, if I recall. These are very hard to find. I think I bought all of the remaining stock that a electronic distributor had. And I bought enough, for the boards that I'm making, and a little bit more. So now we will go ahead and tack this thing down. Well, hopefully. because I can't see it. Like I said, the box is in my way. There we go. And typically like all the others, I'll tack 2 spots down. A little bit of flux. I'll tack the 3rd spot down. And I'll hit the others again, just to make sure. Make them all nice and pretty. There. Now, the one thing that I don't like about this board that's it, yeah. Excuse me. Is the actual, where's it at? There it is. The screws are so super small, right? And if you look on the back of the board, this hole, there's not really a lot of wiggle room, right? I believe this is it. It could be this one. I'm checking to make sure I got the right. No. Which I do. I don't have the right washer. That's fine. Now we get a screwdriver. Usually got to tighten it, and you have to make some little adjustments. Now, this 10K resistor right here can cause a problem in the location that it was originally put in. So what they have found out was that if you're inserting the card a lot, sometimes it may come in contact with the drive cage, or not drive cage, I'm sorry, the PEB cage, and it may knock it off. Well, so I put a little electrical tape on there, just like that. No big deal. So now it's ready to go. We're going to test it in TI mode. So that's TI. I have it set. CRU 1000. And that's what's really cool about this card in Fred's DSR is it allows disk emulation. What that means is if you create a directory, if your disk emulation is on, and you create a directory called DSK1 on your IDE hard drive or your CF card or SD card, however you're hooking it up through an IDE interface, is that it will search there first before it goes to the standard real DSK1, which is typically at CRU 1100. So